I'm DJ Carrillo and I am a peer leader at UTEP. So today I'm going to show you how to solve and how to conceptually get a problem that is similar to your workbook, which is question 15, module 9. So if you haven't already looked at it, you could just continue watching the video, or you could just pause and go ahead and read it and try to, see. Anyways, so I am going to solve a similar question, and it's going to be different values, but the logic should be the same. So what we're going to do is we're going to compare gamma rays versus infrared waves. Okay? So gamma rays versus infrared waves. So a gamma ray has a frequency of approximately 3.00 times 10 to the 19 hertz. And infrared waves have a frequency of 4.30 times 10 to the 14 hertz. So I'm not making these numbers up. They're actually the frequencies that go with the waves that we're talking about, so that's why I was looking down. Anyways, just to, get a picture of what's going on, we have a gamma ray, which it's not to scale, but looks sort of like this. So we have photons that are moving like that. So frequency, right? So the frequency is a lot smaller. So that means that the photon is going to go to a certain path a lot faster. And then infrared waves will look something like this. So these aren't to scale. I'm pretty sure that they'll look totally different, but it's to just to pictorially get what's going on. So we want to compare the energies of the photons of these two waves. So what we're going to do is we're going to use this energy formula that we have. Yeah? So this energy here is the energy related to one photon of the wave. And H is Planck's constant, which is equal to 6.63 times 10 to the negative 34 joules per second. And then V is simply our frequency. So the units of frequency is hertz or per second. And then just to reiterate, energy, the units is a joule. Okay, so I am going to put this on the side or up here so you can see. And I need some room, so we'll do that. So we want to compare the energies. So the gamma rays, we know that the energy of a photon of a gamma ray is equal to Planck's constant. So I'll put it up here just to remind us. So it's 6.63 times 10 to the negative 34 joules second times our frequency, which is given. So 300 times 10 to the 19 hertz. So this energy, and you can calculate it, you can put it in your calculator, and hopefully you get the same answer. But I got 1.989 times 10 to the negative 14 joules. So keep in mind that this is the energy for one photon. And in your workbook, they're asking for a mole of photons. So when you think of moles and really, really small particles, what number do you think of? I personally think of Avogadro's number. So we know that Avogadro's number, is 6.022 times 10 to the 23. So to figure out the energy for a mole of photons, we're going to do the energy we got for one photon times Avogadro's number. And we get that 1 mole of photons, and keep in mind that these are gamma rays, is equal to 1.197 times 10 to the 10 joules. So I'm going to box this in so we keep this in mind. So using this same process, we're going to apply it to the infrared waves. So I'm just going to write this out. We're going to use the same constant because we're talking about waves. So no need to fear. And then we have our hertz, to the 14 hertz. And I pre-calculated this and I got 2.85 times 10 to the negative 19 joules. So using the same logic, we're going to figure out how many moles. So we get 2.85 times 10 to the negative 19 joules times Avogadro's number. And that gives us 1.717 times 10 to the 5 joules. So this is the energy for 1 mole of photons that are of the infrared wave. So I'll box this in. So as you can see here, we can compare the energy. So we have 10 to the 10 versus 10 to the 5. And we also have these values, but 10 to the 10 tells us it's a really big number, right? As compared to 10 to the 5. So we can then assume that gamma rays has a larger number, which if a gamma ray hits your skin versus an infrared ray, infrared wave, photon, hits your skin, a gamma ray that has a lot more energy will be more hurtful to you. So in that case, we know that gamma rays, we don't want gamma rays to hit our skin because they have more energy. Thank you for watching. I hope this was very helpful for you to solve this question. Best of luck.